This video is about quadratic sequences, and we will learn how to find the nth term rule of quadratic sequences. To watch this video, to learn about quadratic sequences, you must be knowing about arithmetic sequences. If you have no idea how to find the nth term rule of arithmetic sequences, go find the link in description and watch video about it, and then come back to this video. So the first thing, this is a quadratic sequence because in an arithmetic sequence the difference is always common, but most probably here it's not going to be the common difference. Let's see. The first one is plus 7, second one is plus 11, third one is plus 15, and it's plus 19. So the difference is not common. If it's common, if the difference will be common, it's an arithmetic sequence. So the first difference will never be common in a quadratic sequence. And to be more sure that it's a quadratic sequence, the second difference you will see will always be common. So 7 to 11 is a plus 4, 11 to 15 again it's a plus 4, and 15 to 19 it's a plus 4. So this second difference, this second common difference, tells you something very important about the nth term rule. The first part of your nth term rule, the half part of your formula, comes from this second difference. What we do is we do the half of the common difference. The half of 4 is actually 2. So that's the first part of your nth term formula, 2n square. Now what we need to do to figure out the rest of the nth term formula, we need to write the sequence, the original sequence again. So let's do it. Let's write the term number first. Term numbers are 1, 2, 3, 4, 5. Then let's write the original sequence. The original sequence is 5, 12, 23, 38, and 57. And then find the new sequence using the half of our nth term. We already have 2n square. Find the new sequence using this part of the term rule. So 2n square is 2 times n square, and n is 1, so 2 times 1 square will be 2 times 1, which is 2. 2 times 2 square, yani 2 times 4, 8. 2 times 3 square is 2 times 9, 18. 2 times 4 square will be 32, and 2 times 5 square will be 50. So now the next step is find the difference between the original and the new sequence. We have to find the difference between them. So 5 minus 2 is 3, 12 minus 8 is 5, 23 minus 18 is 12 minus 8 is 4, sorry. 38 minus 32 is 6, and 57 minus 50 is 7. Now what you have got now is again a sequence. Now you have to find the nth term rule for this sequence, because this sequence is an arithmetic sequence. You see the difference will be same, the difference will be common. Okay, you see it's plus 1, so it's just 1n, or I can also say n, the difference of this one, 1n. Then the difference between the first term and the difference, 3 minus 1 is a positive 2, n plus 2. n plus 2 is the nth term rule for this sequence, which will actually go to our original nth term rule and will add there. So it's positive n plus 2. That's the nth term rule for this quadratic sequence. I know this is confusing and there are a lot of steps to remember, but still I hope the next example will help you remember it. So first thing we do, we find the first difference. So it's plus 4, plus 6, plus 8, and plus 10. Now let's go to the second difference. So second difference is 2, 2, and 2. Now you get the second difference, which is common. It tells you that yes, this is a quadratic sequence. Then this second difference helps you find the first part of your nth term. You always divide it by 2, as we did here. 4 divided by 2. We'll do 2 divided by 2 is 1. It means it's 1n square. Okay, that's the first part of your nth term rule. Now we use this first part of our nth term rule and the original sequence here further. Let's do it. So n is just the term number 1, 2, 3, 4, 5, normal term numbers. We'll write the original sequence here. Original sequence is 5, 9, 15, 23, and 33. And now we will use 1n square, or I can say n square, to find the new sequence. So let's say n square, and n is 1. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, and 5 square is 25. Okay. Now we have to find the difference. We have to find the difference between the original and the one with n square, like we did here. The difference between the original and the one with 2n square, and we found the difference. With the difference, we get a new sequence. Okay, so let's do it here. So 5 minus 1 is 4, 9 minus 4 is 5, 15 minus 9 is 6, 7 and 8. That's our new sequence. It's an arithmetic sequence, means all the differences will be common, and we just have to find the nth term rule for this sequence. So let's see the difference. It's plus 1, plus 1, plus 1. Definitely it's an arithmetic sequence. So the nth term for this one is plus 1, 1n square, or I can also say n square. Oh no, sorry, 1n, not n square, 1n. Okay, and then we find the difference between the difference and the first term. 4 minus 1 is plus 3. So it's 1n plus 3, which will come here with the nth term rule, 1n plus 3. We can also write it as n square plus n plus 3. N square plus n plus 3. So the use of arithmetic sequence and the nth term is very important with quadratic sequences. You have to be good with arithmetic sequences first, and then learn how to find the nth term of quadratic sequences. So let's revise what the procedure is. First, you have your sequence already. You find the first difference, then you find the second difference. Okay, if it's common, divide the second difference by 2, and then you will get the number which is the part of your nth term rule. So you get 1, it's 1n square. You get 2, it's 2n square. Once you are done with this, you write the original sequence again with the term number. Okay, you write the original sequences, and then with the first part of your term rule which you have received, like 2n square here and 1n square here, find another sequence and then find the difference between the original and the new one. Original and the new one. So the difference which you get is actually a new sequence to you, a new arithmetic sequence. Use that new arithmetic sequence to find the nth term rule. Okay, as we used to find in arithmetic sequences, find the nth term rule. That's the rest of the part of your nth term here. So this is how we completely find the nth term rule for quadratic sequences. I hope this video is of help to you. If you want me to solve something else, let me know in the comments. Share and subscribe for supporting our channel. Have a nice day.